Hi everyone, I'm Anna and I'm presenting assignment 1. The conceptual focus that I have chosen is choosing appropriate graphical displays. It is part of Auswell's Level 5 and 6. It is part of the Statistics and Probability strand. Students at Progression Point 4.5 that are working towards Level 5 are expected to identify or describe different ways to collect data. This could be through observation or survey, and they are expected to know different forms of representations, such as graphs and tables. Moreover, they are able to display data in graphs or tables. They are able to examine the usefulness of graphical representations. So this may mean that they know that graphical representations are a better way in showing raw data. At this level, they learn to make picture and column graphs that represent data values. Here's an example of two graphs that students should be able to recognize at this level. At the left is a column chart, and at the right it is a picture chart. Now these are fairly simple. Students at Progression Point 5.5 working towards Level 6 are expected to come up with appropriate questions, gather data, and use relevant displays to represent the data. Students should be able to make comparisons of different data sets. At this level, students are learning to compare the effectiveness of different forms of data displays. They learn that some graphs are more appropriate than others. They can come up with appropriate survey questions, and they can define and distinguish between categorical data, numerical data, observation, survey, sample, and population. At Level 6, students are expected to be able to compare different data displays. Students are able to compare estimated and actual results of data. This could be an estimation before conducting an experiment and comparing the actual results with their predicted results. They can interpret and evaluate data from secondary sources. So that means that they are able to read the results from other experiments. Now we are going to talk about the major concepts and prior knowledge needed when choosing appropriate graphical displays. Students need to know the whole process of collecting data, sorting data, and making them into graphical displays. Students need to understand how raw data can be sorted, organized, and displayed in graphs. They need to know and understand how to create different graphs with data, with or without the use of technology. Interpreting and reading different graphs. So at this stage, they should be able to identify a range of different graphs and know how to read them, such as histograms, bar graphs, pie charts, etc. They need to understand the advantages and disadvantages of different graphs. They need to be familiar with the common use of particular graphs. For example, pet ownership of a particular class can be displayed in a pie chart. And they also need to know that the same data can be displayed in different types of graphs. So our previous example about pet ownership in a particular class can also be displayed in a bar chart, not just a pie chart. The conceptual difficulties associated when choosing appropriate graphical displays could begin with data collection. Some students get confused when it comes to collecting data. They may be collecting data that is irrelevant to the question they pose, or they may be collecting data that may cause error in their experiment. When students make bar graphs, for example, they may also be confused about making an appropriate scale. So for example, let's imagine a bar graph. and on the y-axis, students may struggle to be able to come up with an appropriate scale that will fit their page. When I was on placement, my students made bar graphs and they had to count their scale by twos. So it went 2, 4, 6, 8, 10. And my grade 2s were actually quite confused about how this worked and how it was the same as going 1, 2, 3, 4, 5. Students in Calaco's study struggled to differentiate between the number of answers and the number of participants. Now sometimes, and this happened in my placement as well, sometimes one participant may make more than one vote. So some students may struggle to understand this because they assume that one participant makes one vote, and this is not necessarily true. According to Murillo, students struggle to associate the y-axis as the independent variable and the x-axis, as the independent variable and the y-axis as the dependent variable. Students can overcome this by revising the terminology of these words. They need to understand and know what an independent variable is and what a dependent variable is and how they are associated with each other. Calaco found that conducting experiments based on real-life context enabled students to better understand data collection and data analysis processes. This may be because students can understand how an experiment can be put on paper. At this level, students know how to construct graphs under a teacher's specific instruction. However, they are unfamiliar in selecting appropriate graphs for different questions. So we assume that students at this level so far know how to construct graphs just based on the teacher's instruction, but they don't know how to select graphs if they were given a question. Now we are moving on to the misconceptions associated when choosing appropriate graphical displays. Students may generally perceive some graphical displays as better than others. This may arise when a teacher may use one particular type of graphical display, such as a bar graph, the majority of time they are teaching. So for example, during my placement, my mentor teacher used a bar graph most of the time she was teaching statistics rather than using a range of different types of graphs. Now, this may cause bias in the student's preference when choosing a graphical display. Students may also think there is only one correct way in representing data. Rather, there are many correct ways to represent data, just some are better than others. One reason is because students have previously been told what graph to use by the teachers or instructors. They may also fail to understand that some graphs are better than others depending on the type of question they pose. So different questions have different graph preferences. And students may think that because there is no wrong answer in picking a graph, it is alright to randomly select a graph. And this is not true because students are encouraged to select the most appropriate graph for their questions. The digital tool teaching activity that I have chosen aims to develop the ability to select appropriate graphical displays and to know when a graph is suitable in displaying data sets. The targeted misconception or conceptual difficulty is first the failure to understand that some graphs are better than others depending on the type of question they pose. And students may think there is only one correct way in representing data. Rather, there are many correct ways to represent data, just some are better than others. The materials required in this teaching activity are, first, access to Maths is Fun website. This is an excellent website that helps students and teachers develop bar graphs, pie charts, histograms, so a range of graphical displays can be computed through this website. Students will also need access to Word to create a table of contents, PowerPoint to make their presentation, and other useful websites they may need through their research, or perhaps constructing a graphical display that Maths is Fun cannot do. Here is the method of the digital tool teaching activity. Step 1. Students will pose their own research question. This could be the class's favorite color, their favorite subject, what pets they have at home, how many siblings they have at home, for example. Number 2, they are to gather the relevant data and tally their results. Students are required to research the pros and cons of different graphical displays. They are to select 2 different graphs and create them using the Maths is Fun website, or other websites as well. They are to present these graphs on PowerPoint slides, and students will present their data in a table form. Then select 2 graphs that will be accompanied by their pros and cons in presenting the data. Students will select a winning choice of graph and give reasons as to why the student thinks it's the most appropriate graphical display to answer their particular question. And finally, they are to present this in front of the class and stimulate guided class discussions for their choice of graphs. This discussion will be very important as it will enable students to use their knowledge of graphs to think about what is most useful in answering particular questions. This is an example of my digital tool teaching activity. So the question I have posed is grade 5A's favorite colors. Students are required to tally up the results that they have found and to create a table to display their data. So here I have tallied up all my survey results and have put all my answers in a table like this. After doing thorough research on different graphical displays that may be relevant in answering my survey question, I was able to narrow it down to 2 graphs. The first one is a bar graph. The positives of a bar graph is that it is good in showing different categories. In this case, it is different colors. Moreover, it can easily identify the most popular and the least popular color. So in this case, green is the most popular and pink is the least popular. And it always has an accurate scale, even when done by hand. Now we can see this on the y-axis, where each number is spaced out evenly. The cons of a bar graph is that it may be ineffective when there are too many variables on the y-axis or on the x-axis. The second graphical display that I have chosen is the pie chart. The positives of a pie chart is that it is easy to see how one variable compares to the rest. So for example, we can see pink in the chart has a much smaller portion compared to the rest of the colors. It also enables a good overview of all data and it shows completeness or wholeness. The cons of a pie chart is that portions may be inaccurate, especially when done by hand. And another con is that it is hard to determine the exact numbers, of course when numbers are not labelled. And after deliberating between the two graphs, I have chosen the winning graph, which is the bar graph. I've chosen the bar graph over the pie chart because it is easier to create, as there is a clearer scale on the y-axis. It enables readers to know exactly how many students like a certain color. So for example, it is so easy to see that 9 students like the color green. And it is easy to see which color is the most popular and the least popular, depending on the height of the bar. The students will end their presentation by asking their fellow peers and classmates whether they thought he or she made the right decision. This will stimulate good classroom discussions and will make students think using their knowledge that they have about graphs. This will be a very good reflective activity. This activity counters students' misconceptions as it enables students to see that there are multiple ways to showcase data displays. When they research on different graphical displays, they can see that there are multiple ways to display their data. It also requires them to do their own research and to learn more about different graphical displays. Using the information that they have learnt through their research, they are able to develop skills to make informed decisions about choosing the best graph to display their data. They also have the opportunity to discover that some graphs are better than others for their own question. Thank you for listening to my speech.